Sustainable engineering focuses on how well the engineering team is able to maintain the pace of adding new features and making changes to an existing code base in the long term. Here's a typical scenario. The engineering team works through the first 10 to 15 stories at a rapid pace. From that point on, there is a gradual decrease in the velocity of the team. One of the key reasons this happens is because of increasing technical debt. In this video, we'll take a look at what technical debt means and its negative effects. We'll then talk about solutions to effectively pay off technical debt on a consistent basis. So what is technical debt? Very simply, they are shortcuts that programmers end up taking within the code. While this could be attributed to things like lack of discipline or training, shortcuts are also taken by mature programmers once in a while. This mostly happens while racing against a deadline. Examples of such shortcuts include bad code design, hard to read code, and not enough automated tests. Bad design results in making the code base inflexible and hard to extend, thereby making it inefficient to add new features or change existing ones. Bad design can also result in making the code brittle and making it much more vulnerable to bugs. Hard to read code refers to poor naming conventions and long classes and methods. The ideal case is when a programmer who's new to the code base can figure out the system with little guidance from the original programmer. When that is not the case, precious programmer minutes get wasted in trying to figure their way through a cluttered code base when ideally they should be focusing their energies on building new features. We've already seen the value of automated tests in the collaboration video. A good code base has an accompanying suite of tests that drives it through a comprehensive set of scenarios. As new features are built, the accompanying test suite has to be parallelly maintained. If bugs are discovered in the code, then new tests need to be added to ensure those bugs don't happen again. When not enough attention is given to the test suite to do all of these things, technical debt starts to mount. Technical debt happens because it's never urgent to take care of it, because they're invisible to the end user of the product. And for the most part, invisible to you, the customer as well. Unless, of course, you invest time to read the code, which again, we don't expect you to do. What about bugs? Should we consider them as technical debt as well? The short answer is no. As mentioned in the previous slide, technical debt is invisible to the user. Bugs, just like features, are quite visible to users in most cases. The exceptional cases being things like difficult to detect security issues. Let's look at the impact of technical debt over time. The goal is to have an increasing number of features being pushed to either staging or production for us to get feedback on a constant basis. The blue line indicates how things happen in the waterfall world. There's a good amount of emphasis on upfront infrastructure and design here, so technical debt is not much of a problem here. Unfortunately, there's no working software being released for a long time in this case. The red line indicates how things happen on an agile team that's not paying sufficient attention to technical debt. There's an acceleration in terms of delivery of new features in the early phase of the project, but the technical debt soon catches up and then impacts the velocity of the team. The green line reflects the value of paying off technical debt constantly. There is a constant and predictable rate of a growing number of working features in production. Before moving to the solution, let's take a quick look at the economic impact. Gartner did a study and came up with these astronomical numbers. Please read the article linked to below for more details. So what's the solution to avoid increasing technical debt? It's of course to pay off debt on a frequent basis. But how does the team do that exactly? There's not one, but many practices that we follow. Following a BDD approach ensures that writing tests is never left as an afterthought, since the programmers never add or change a single line of code without having a failing test first. We've discussed the value of the additional discipline pair programming brings in, and this is useful for paying off technical debt as well. Refactoring is defined as modifying the code while keeping its output constant. This is done with the goal of cleaning up the code every so often. This includes activities such as improving naming conventions and removing redundancy in the code. Incremental design and evolutionary architecture are two other methods of refactoring code as well. These concepts help programmers deal with the constant changes during the project while working on an ever-expanding code base. Both of these concepts Encourage constant and incremental investment in both design and architecture throughout the project. Finally, code analyzers and external code reviews are two methods we use to get additional feedback on the quality of the code, to help the programmers look at their own code from multiple perspectives. All of these activities are done in parallel throughout the construction phase. Thanks for watching. In the next video, we'll take a look at the concept of continuous delivery and how it helps lean startups accelerate their build, measure, learn cycle.